Okay, now that we have derived these four basics of the imaginary number system, what this allows us to do is be able to simplify I that's raised to any power. So let's say we were given the problem I to the 26th. We saw in that last video that these four answers, I, -1, -I, and 1, are going to continue to cycle through. So I can predict that I to the 5th, based on what we did previously, would be equal to I to the 6th would be equal to -1. I to the 7th would be equal to -I. I to the 8th would be equal to 1. I to the 9th would be equal to I. I to the 10th would be equal to -1. I to the 11th would be equal to -I. I to the 12th would be equal to 1. And I could continue on and on and on until I got to 26, or I to the 26, to solve this problem, simplify this problem. But I want to develop a rule here. So of these four answers, this guy right down here, this I to the 4th, he's got the simplest answer. There's no negatives in his answer. There's no imaginary numbers in his simplification. He's just got a plain +1 answer. So I always want to think about how many groups of 4 are within my expression. So if I say I to the 26, I need to think about how many groups of 4 are within 26. And if I think about this, I'm just going to use my head, do some quick division. 4 times what is going to get me close enough to 26? 4 times 6. 4 times 6 would get me to 24. So I'd need how many more I's to make 26? I'd need 2 more. I got 24, so I need 2 more. This is stemming from our properties of exponents. We're using the fact that I can create groups of exponents raised to a power, and I know that those exponents will be multiplied together. And then if I have a separate group that's being multiplied by my other group, those exponents will be added together. So this gives me 24 I's in this expression, 2 I's in this expression, which together make 26 I's, which is equivalent to my starting problem. Well, what do I know about this expression, I to the 4th? I know, based off what we've already derived, that I to the 4th is 1. So what's 1 to the 6th power? Well, that's just 1. That's why I looked for that. That's the easiest expression, because 1 to any power is always going to be 1. What do I know about I to the 2nd? I go back to what we've already derived. Its value is -1. So I end up with an answer of 1 times -1, which gives me -1. Now it all boils down to the fact that I to the 26 is the value of -1 because there are 2 I's that are left over when you think of groups of 4. That's how we need to think about every problem. So what if I gave you I to the 1004? I want to start out thinking about groups of 4 within 104. So how many groups of 4 could I make within 104? If I have my calculator, I could certainly do my division. 104 divided by 4 is going to give me 26. But if I didn't have my calculator, then real quick, I know that 4 groups would go into 100 25 times. So 4 more would make 26. Do you have any I's left over? No. If we have 4 groups of 26, we've got 104. So what do I know I to the 4th is equal to? That value is 1. And 1 to the 26th power is 1. So I know this guy was equal to 1, and he would match up with I to the 4th because there's a perfect group of 4's in that answer. Sometimes when we have these problems, they'll throw a coefficient in the front, something like 3I to the 15th. Now all that's going to do is require that I remember what a coefficient does. A coefficient in front of an expression, even if it's an imaginary, means multiplication. So this expression is the same thing as 3 times out of the 15th. Now, out of the 15th, I'm going to simplify like I did earlier. So I'm going to think about the groups of 4. So how many groups of 4 could we get in out of the 15th? Well, 4 groups would be too many. That would put me at 16. So I can only get 3. And if I get 4 groups of 3, I've got 12 i's. How many more would I need to make 15? I would need 3. So I've got more to multiply here, but I know exactly what I'm doing, and the process is the same. I'll bring my coefficient with me. I know that out of the 4th is 1, and 1 to the 3rd is 1. So that gives me 3 times 1. And I know that out of the 3rd, using what we've already derived, is equal to negative I. So I'll need to multiply 3 times 1 times negative I, which gives me negative 3I. So using these powers of I need to make sure that I never leave a power on I bigger than 1. They can always be simplified to be one of these 4 original answers, and a coefficient in front will sometimes change that value, but I'll always see the leftovers being an integral part of my answer.